what parts of functions, if you had to say what is one area of function that you're struggling with, and what's one area where you kind of feel comfortable, I'd like everybody to make one comment. So one area where you want to try and get better with functions, and one area where you feel like, okay, I've kind of got this. Today's focus is going to be on the graph called the hyperbola. And I will make some comments in a moment about how the hyperbola behaves. And we're going to focus on how do we sketch the hyperbola. But before I start that, I just want to give you a moment to put the comment in, or you can raise your hand and let me know audibly. Sometimes that's quicker. And then just a big welcome to Anushka, Callan, Manila, Mikateko, Naledi, Njabulo, Mfundo, and Tandwayo, who are all in class. And I think there are still a few more students joining. Okay, so while you're making your comments, let me write down the standard form of a hyperbola. But even if that's the standard form, probably the simplest hyperbola would be something like that. So that's sort of like the simplest hyperbola possible. And this is the standard form of a hyperbola. Okay. All right. I'm taking the, I understand the range, but I understand the rest. Okay. So range is something that maybe Cal and I can work in today as we go about doing questions. The exponential one, so Mfundo, luckily, exponential one is coming up soon, so we're going to do that. So that's coming. But if you want to look at last year's videos on exponential, there is a top-up slideshow on functions in Google Classroom. So if you've got an exam like tomorrow or whatever, don't be afraid to go to the top-up slideshow in Google Classroom, which has last year's lessons on the exponential. Okay, let's start today. So what is the hyperbola? It's one of the big four functions, and sometimes we rewrite it so that instead of having y the subject of the formula, we can rewrite it so that it's two variables multiplied together to give us a constant. In this case, it could be 1, but sometimes people write it as x times y is k, where k is the constant. It's all a little bit weird, I guess, but let me show you an example of what the graph looks like, just to give you a feel for it. So the hyperbola has a rather interesting shape. If the value, the constant term, is a positive, it would be in this quadrant and that quadrant, because when you multiply a negative by a negative, you get a positive. And when you multiply a positive by a positive, you get a positive. So this graph of y equals 1 over x is going to be in these two quadrants. And it's going to look like that and like that. So that is the graph of y equals 1 over x. Okay, but what if, something else I want to point out. If you had to draw a dotted line like this, we would say that the graph is symmetrical across the line y equals x. You can basically fold this graph this way, and you can also fold it this way. This would be the line y equals minus x. So hyperbolas are symmetrical across these diagonal lines. Give me a thumbs up if you understand what I mean by symmetrical across these lines. Like you can fold the one side over the other. Give me a thumbs down if I've lost you. Just want to get a sense of how people are feeling about symmetry, because the hyperbola has a lot of symmetry, and it's important that we kind of start by at least having a look at something like that. Okay. Let me take the symmetry lines away for now, just because otherwise it gets a little bit confusing if there's too much. But you kind of know what I mean about that. Now, this is the graph of y equals 1 over x. But what if I wanted to draw the graph of y equals minus 1 over x? Okay. Now that graph is no longer in quadrant 1 and 3 because of the negative value here. This negative constant value, the negative 1, means the hyperbola has to be in quadrants 2 and 4. And so if I had to draw that graph, it would look like this. And again, it will be symmetrical, but notice how it's in different quadrants. Now, there's something weird happening here. Why does this graph never ever cut the x or y axis? I noticed that all the other graphs I've done so far, they'd cut the x-axis or the y-axis. This graph doesn't seem to be cutting any of the axes. It seems to be avoiding them. Like, what is that called when the graph avoids the axis? Okay, it's called an asymptote. Well done, everyone. So if you look at these graphs, the simple one, x cannot be 0 and y cannot be 0 for both of these graphs. X cannot be 0, y cannot be 0. And that's because if I put a 0 in the division, it breaks one of the golden rules in mathematics. So that's why that happens. And so visually, what happens is with the hyperbola, you can't see them here because they're on the axis, but they're these dotted lines, which are basically like don't walk here lines. They say the graph may not cross these areas. And so when you see dotted lines later today, those are what we call asymptotes, and they're basically avoiding the place where we would cause division by 0. Now, that's a lot of like work. What I think maybe I should do is show you this in practice. So let's do an example let's just do some examples, and then I will give you a format you can use to draw these graphs. So if I look at this, sketching this hyperbola, how do I know it is a hyperbola? Because maybe I think it's a straight line. It kind of looks like a straight line. And the key thing is that the x is at the bottom. Now, if I was to draw this hyperbola, I want to ask you, what quadrants would I draw it in? So that's quadrant 1, 2, 3, and 4. What quadrants would this hyperbola be in? I want you to tell me in the chat which quadrants you think it will be in. Okay, everyone knows it's the second and the fourth. And the reason they know it's this is they know that there's a -5. And so this type of hyperbola is going to look like that. And we can label it y equals -5 over x. Now, the magic asymptotes are actually not being shown yet because they are actually hiding underneath the x and y axis. But later on, we'll start to see asymptotes that leave the safety of the x and y axis. Now, for bonus points, I want you to tell me, let's have a look here. I want to know a point on the hyperbola, and I'm going to give you an x value, and that x value is 3. Can you work out for me the y value that goes with the coordinate x is 3 for this graph? So it's a little bit interesting, but we know that there's a point on this hyperbola. I want you to tell me what is the y value that goes with the x value of 3. And I'd love you to put it in the chat. What is the y value going to be? So remember, you've got the equation of this hyperbola, and I'm telling you that x is 3. What y value will go with that? Is it a positive? Is it a negative? Is it a whole number? Maybe somebody can tell me. Who can tell me what I should do? You can pop your hand up or you can put it in chat. I need some directions. Ah, yeah, there we go. There we go. Mikateko Mfundo, you're quite right. You would take the 3 and you sub it into the equation where the x is. And I will get the value minus 5 over 3, or you can even say it as minus 1 and 2/3. And really, you can see this visually. This is minus 1 and 2/3 over here. So, and what you'll notice with a hyperbola is when you multiply, in fact, let me write it as minus 5 over 3. One of the cool things about the hyperbola is that when you multiply the x and y together, so 3 times that, what you notice is you always get the constant number that this started with, which in this case, it was a minus 5. And so that's one of the properties of a hyperbola. Okay, let's go on to something a bit more exciting. So, ooh, that got a little bit too exciting too quickly. Let me zoom out of that. This is a hyperbola, but something is different about it. So before I start drawing it, can someone tell me what is different about this hyperbola compared to all the other ones? I'm confident it's a hyperbola because it's got an x in the denominator, but what is different here? And you can put comment in the chat or you can raise your hand and just tell me audibly. Either is fine. But I need some feedback. What does that 1 do? Okay, so it has a +1, absolutely. So that's the key difference. There was no extra term there before. If we go back to previous things that deal with graphing, a +1 would normally shift the whole graph upwards. So we've got an interesting problem now. So if I wanted to draw this graph, because the value here is a 1, a positive 1, I know I would normally be in these 2 quadrants. But now this +1 is going to cause a bit of havoc. Well, not havoc, but... And so what's going to happen is the asymptote that used to hide here, the horizontal asymptote, it is now going to be sitting over here because it's moved up, and this is going to be the line y equals 1. But now, when I draw my hyperbola is going to look like this. And oh my goodness, okay, that's not the best hyperbola in the world. But now, all of a sudden, I have an x-intercept for my hyperbola because it shifted up, everything shifted up, it now cuts the x-axis. So I want you to find me the x-intercept of this hyperbola. What should I do to find the x-intercept of any function? What do I normally have to do to find the x-intercept? Yes, I have to let y equal 0. Okay, so if you let y equal 0, then you have that equation to solve. Can you solve that for me? Get me a value of x from this equation. So I made y equal to 0. Can you help me find a x value, which I'm hoping will be this one down here? So over to you guys. You work it out for me. What would you do? Or another way maybe of doing it is to say what value of x will make this thing something, which together makes it 0. There's 2 ways we could do this. We could do it a long way or a short way. Who has a value for me? So I get the value -1 for my x-intercept. Now, another way of doing it, you could have done it the long way like I did it here, but you could also ask yourself, what does this value have to be so that something plus 1 gives you 0? And I would say that this thing has to be minus 1. But what's the only way this whole blue thing will be minus 1 is if x is minus 1. So we call that by inspection. So you could do it by inspection, or you could do it by solving. Those are the two ways. Give me a thumbs up if you understood how I got the x-intercept of minus 1. Give me a thumbs down if you didn't follow it. Let me see the thumbs. Okay. So I want to now move to a different, I know I'm doing lots of examples, but the second half of the lesson, you guys are going to draw like crazy. So I want to ask, what is different about this hyperbola? So what happens here is we call this a vertical shift. So this is a vertical shift, and we call this part here a horizontal shift. And what we need to do with hyperbolas is we need to look at these numbers. And when we're going to draw a hyperbola, we start by writing down the asymptotes. You know those lines we said earlier on, the asymptotes tell us to go. And so what is asymptote? But the other asymptote is going to be the thing that causes division by 0. So what x value would cause division by 0 here? What x value would cause division by 0 here? It would be minus 4, yes. Because if you put a minus 4 here, minus 4 plus 4 is 0. So now when you are drawing your hyperbola, the first thing you do, step 1, is you write down your asymptotes, because your asymptotes are your guiding lines about where you are allowed to go and where you are not allowed to go. So this basic hyperbola has been shifted down. So I'm going to draw a horizontal asymptote at y equals minus 2. But I'm also going to draw a vertical asymptote at x equals minus 4. Now, what has happened is it used to be that the hyperbola was centered over here. But because of the shift down and the shift across, this hyperbola that I'm going to draw is actually centered over here. Now, am I going to be in quadrant 1 and 4, or am I going to be in quadrant, well, okay, let me give you it away. The thing that you look at is this positive number, which means that your hyperbola has to be, okay, it has to be in over here and over here. So what I'm going to do is I'm going to draw my hyperbola like that, and then I'm also going to draw it like this. Now that looks a little bit different. Now, here's something interesting. There is, in fact, a y-intercept and an x-intercept in this hyperbola. Can you please find me the y-intercept and the x-intercept for this hyperbola? So it's going to be over here and over here. Now, I'll give you a hint. To find the y-intercept, you make x 0. To find the x-intercept, you make y 0. I want you to go and find the x and y intercept for me. And then when you have got it, I want you to put it in the chat. And I'll put you as step 2 for my hyperbola. So for step 2, we're going to say intercepts. We need the intercepts. How do we find the y-intercept? What are you guys getting for your y-intercept? You can put in your calculators, but you get a quarter minus 2, so minus 7/4 is what I get. And the y-intercept would be over here. So this is going to be minus 7/4. And that makes me feel good because I can see that's correct. Perfect. Naledi agrees. Okay, now we need to find the x-intercept. So we need to solve this equation now. So there's a couple of ways we can do this, but I'm going to bring the 2 across. Okay, now I think, I don't know, can any of you see the answer straight away at this point, or do you think I probably need to do a bit of working out? So I'm going to bring the x plus 4 to the other side, and I'm going to get 2 times x plus 4 equals 1. And then I'm going to bring this 2 across. So I get x plus 4 is a half. This is a bit more working out. And then I'm going to take away 4 from both sides. And I'm going to get minus 3.5. Or minus 7/2. Give me a thumbs up if you followed how I worked out the x-intercept. Give me a thumbs down if you didn't understand it. And I'm going to go and label this over here, minus 7/2. And then the last thing I have to do is I just need to label my graph, 1 over x plus 4 minus 2. Give me some votes to go on. How are you feeling about that working out? All right, so how do we sum up what we've done so far? In order to draw a hyperbola, okay, there's 2 steps. Step 1, write down the asymptotes. Actually, there's 3 steps, but yeah. Then you work out the intercepts, and then you sketch the graph, or you basically, you sketch. So before we have a break, I want to do one more example with you, where we go through this process. So, and then after the break, you're going to do a whole bunch of stuff by yourself. So let's start with this one over here. I want you guys to tell me what are the asymptotes for g of x. What are the asymptotes for g of x? Write them in the chat. What are the asymptotes for this hyperbola? So the asymptotes are going to be y is 4 and x is 8. Okay, now, before we sketch the graphs, the sketch is only the 3rd step. I want you to work out the x and y intercepts for this hyperbola. So now I've done my teaching. I want us to start practicing the whole process. So you are going to find me the y-intercept, and you are going to find me the x-intercept. Over to you guys. What is the y-intercept? What is the x-intercept? I'll give you a little bit of help by putting the So if I take 0 and I put it into this expression, I'm actually just saying 8 of them, so minus 1 plus 4. So my y-intercept is 3, or if I was writing it in full coordinate form, it would be 0, 3. What is my x-intercept going to be? What is my x-intercept going to be? So I need to make y 0, and this has to be 8 over x minus 8 plus 4. Now, I don't know if everybody will be able to see this straight away. It's probably, for a lot of you, good to do it the long way. But the inspection way would be this. It would be to say, in order for this to be 0, what does the blue block need to be? In order for this to be 0, this would have to be minus 4. Okay? But now, how do I cause this whole thing to be minus 4? What x value would cause the whole blue block to be minus 4? So at the moment, 8 divided by minus 8 is minus 1. So if x was 0, that wouldn't be very helpful. What value of x, if I put it in here, would cause the blue block to be minus 4? And if I think about it, I want this to be minus 2. So the only value here that would work would be x is 6. Now, that's the short way of doing it. If you didn't like that way, that's not a problem. Then the longer way to work it out, and I'll just show you that it does work, it just takes a bit longer, is you would take it to the other side. So minus 4 equals 8 over x. Oh, my pen is being strange. X minus 8. Okay, I don't actually have the full amount of time yet, but if you work it out, if you move this across and move things around, you will see that x is 6. Okay, I need to give you guys a break. So let me show you how I would sketch this hyperbola. And then after the break, you are going to sketch for me. So step 1, I draw my Cartesian plane. Then I'm going to put the first asymptote line, and this is y is 4. And then I'm also going to put a second asymptote line, which is going to be, now I know this is not perfectly to scale, but this is x is 8. Now, do I know where the hyperbola is drawn? Well, I do know that it was a positive number here, which means it should be in this quadrant over here, and then also in this quadrant over here. I'm going to label this. This was 6. I'm going to label this. This was 3. And then I'm going to label the equation of my graph, which was g. Give me a score out of 10 for how well you've understood that. Whereas 10 is perfect, 0 is nothing, 5 is like sort of get it, but like, I need some more practice. Give me a score out of 10. And then we're just going to do a very quick energy break and come back and do a couple of examples by yourself. Okay, so before we go off and have a break, I want to reinforce the 3 steps. It's find the asymptotes, find the intercepts, and then the third step is to sketch the graph. And that's all we're going to do in the second half of the lesson. But you know how it is. We need to take some time to just relax. So what I want you to do is I want you to join me in standing. And all we're going to do today, it's like a 1-minute break, is we are just going to put our arms out to the side. We're going to move them around a couple of times. Then we're going to change direction. Okay, then we're going to shake our arms out to loosen up. Shake out this arm. Shake out your legs. Okay, and then we're just going to do 12 jumping jacks. So 3, 2, 1. Make sure the space around you is clear. Let's go. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, and then let's just shake out our arms one more time. Nice and loose. Shake out the arm. Shake out the legs. And today was a very quick break because we need to practice. Okay, so I want you to do the 3 steps all by yourself on this hyperbola. So I'll let you fill stuff in the chat. So step 1 was asymptotes. Step 2, not x, it's just intercepts. And then step 3 is to sketch. And I will watch the chat and give feedback based on what I see in the chat, but I want you guys to try and sketch this hyperbola f all by itself. Go for it. Okay, I see some early. Okay. So I agree from what I'm seeing in the chat that the asymptotes are y equals -2 and x equals -4. Now, that's step 1. I want to see what people get for the intercepts, for the x and y intercepts of this hyperbola. Yay. Ooh, it's not +4. Okay, this is a bit of a sneaky one because in order to get the asymptote, I need to cause division by 0. So if I make this 4, 4 plus 4 is 8. So this actually x, in order for the asymptote to exist, x has to be -4 in this case. Does that help, Anushka? Because basically, another way of getting the asymptote is to go x plus 4 must be equal to 0. So therefore, x is -4. Perfect, Anushka. Perfect. Okay, what are we getting for our x-intercepts? So y equals 0. Now, I'm starting to like this inspection way a lot. So let me see if I can help people to see this. I know this thing has to be 2 because that's the only way I would get 0. Now, at the moment, this is a quarter. How could I force this thing to be 2? Hmm. Any ideas? Well, this is a little bit harder, so maybe I should do the longer way. So it's not obvious to me right now how I would do that. So what I'm going to do is I'm going to do a bit more working, and I'm going to move the 2 to the other side. Okay, now what I'm going to do is I'm going to keep this thing as a bracket, and I'm going to get that. Now, just follow what I'm doing. So I've left the 1 on top, but the x plus 4 is moved to this side. Now I'm going to move this 2 back to the other side, and I'm going to get x plus 4 is equal to a half. What do you think my x-intercept is going to be? So sometimes inspection is easy. Sometimes it's a bit harder. So sometimes you have to do the long way. What do you think my x-intercept is going to be here? Who has some ideas? I think I take away 4 from both sides, and I get minus 3.5, or I could say minus 7 over 2. Okay, so now I've got all my intercepts. I've got all my asymptotes. I want you guys to draw the graph. And when you have drawn the hyperbola, I want you to tell me done in the chat. So I want to give you a chance to take all this information. Okay, so you've got this information here. You've also got this information here. And then you've got this information. Well, maybe I should put a big block down over here. And that's going to help you to sketch this hyperbola. But I want to give you some quality time to sketch this hyperbola by yourself. So I need you to tell me down in the chat before I give you the final answer. Let's start by putting in. Okay, I actually drawn my scale is a bit off. Let me. So I always find doing the asymptotes is almost like you're telling myself, look, that used to be all hyperbolas used to be here, but this one is centered here. Now, because it's a positive value for 1, I need to decide where am I going to draw the lines for this hyperbola. And for me, it has to be the new quadrant 1 and 4. So this would be something like that. But then remember, you also have this side. And I may not cross these lines. And then I've still got to actually fill these values in. So this was minus 7 over 2. And then this was minus 7 over 4. And then I have to label the graph f. Now, we don't necessarily draw in these asymptotes, sorry, these axes of symmetry, unless they ask us. So for now, I'm leaving that bit out. Okay, I want to give you a chance to draw one more hyperbola today. I'm going to leave this example up on the board that is there. But for those who are feeling comfortable, I want you to attempt one more hyperbola, which is the graph of minus 5 over x plus 2. So I want you to try and draw the hyperbola of minus 5 over x plus 2. For those who will ask questions, please do ask us a question in the chat, and then let's go from there. Okay, so what is step 1? So for this one over here, the asymptotes are quite easy. It's just x is 0 and y is 2. Once you have done your working out, I want you to start drawing this hyperbola. So I'm going to give a bit more time for the working out, but once you've done the working out, I want you to, oh wait, let's have a look here. X is 0. I'm not allowed to make x 0. Interesting. So if I'm not allowed to make x 0, what does that mean about the y-intercept? Because I was going to put to find the y-intercept x is 0, but actually I'm not allowed to do that. So there is no y-intercept. Because if I put a 0 here, I would have division by 0. I'm not allowed to do that. So in this particular hyperbola, there's no y-intercept. Now, what about the x-intercept? Is there an x-intercept? Well, to get the x-intercept, I need to make y equal to 0, and there's no rule against that in this case. What is my x-intercept going to be? Well, I think I'm going to have to do this the long way. So I'm going to bring this across. So I bring the 2 to the other side, and then I'm going to move this x next to it. So I get minus 2x is minus 5. And then I divide both sides by minus 2. So I get 5 over 2, or 2.5, as my x-intercept. Now, I've got my asymptotes. I have got my intercepts. What I need to do is I need to draw this graph. So I want you guys and girls to draw this graph now. And then when you are done with drawing it, please let me know so I can come along and show you my answer. Now, there's no y-intercept, so that probably means the asymptote is on the y-axis. So x is 0. What is x? Oh, here we go. X is 0 is literally on that. And y is 2. So the only asymptote that I see is here. Now, where am I going to draw these things? Am I going to draw them here? Am I going to draw them there? Where are the two halves of the hyperbola going to be? Which quadrants are they going to be in? So what do we have to look at for quadrants normally? So we normally look at the number in front, but now here's the sneaky bit. With this one, it's actually minus 5 because there's a negative there. And so the quadrants are going to be 2 and 4, although they have shifted. So what you're going to have, no, not 4, that would be positive. They're actually going to be here. No, they're not going to be here either. Yo, I'm having a moment. Where are they going to be? They are going to be in quadrant 2. You're right, 2 and 4. Yeah, they are. They're going to be here and here. And what is that x-intercept value going to be? This x-intercept value is going to be 2.5. Is there a y-intercept? No, there's no y-intercept. And then what was the label I used? I used g. And at this stage, that is all we have to do. Now, I know the scale of my drawing is a little bit off, but just remember that red part can never cross this. So it sort of goes away. Okay, are there any questions or comments about this last hyperbola thing? Because I think then I'm going to bring today to a close. But I just want to kind of summarize that and see if there are any questions about it before I kind of wrap it up today and share the quiz link. Okay, yeah. How do I find the range and domain? Oh, that's a good question. Okay. The range and domain in hyperbolas are actually not too hard, but let me kind of go here. For the domain of the hyperbola is any x value, except it may not be the asymptote. So we say x cannot be equal to 0. For the range, we say y can be any value, except it may not be the asymptote. What was the asymptote? The asymptote was 2, so y may not be 2. So what domain says, it says all the allowed x values. And so all the allowed x values are everything except 0. And for the range, it's everything except 2. Right. Does that help with domain and range? Does that make sense? So what I want to do to finish today is I want to share the weekly quiz link in the chat. So maybe just before you go off and do that, let me look at the other example that I did above here. I don't know if I can zoom out anymore. So for the one above, if we look at the example above, in case those who are interested in domain and range, so in this one, the domain, so x could be any real number, but it may not be whatever the red dotted line was, which was minus 4. And for the range of this one, it could be any real number, but for this one, y could not be minus 2. So that would be for the one above. That would be the domain and range. Okay, everyone, that is tonight's lesson.